Okay, welcome back. So today we're going to be fixing a bug that's been part of the series for probably 20 parts now. The issue is if we have a Boolean value and then we leave the scene to a scene that has no references to that, and then we come back, it doesn't remember what it should be. So we're going to fix this, and yeah, let's jump right in. Okay, so welcome back. Today, we're going to be taking a look at how we can make sure that our data is always being saved. Currently, I kind of talked about this already. There's a treasure chest here, and we want the treasure chest to remain open when we go from one scene to another. And I had thought I had fixed that issue by adding in the bool value, but after playing this again, if there isn't a reference to the scriptable object in the next scene, it deserializes, meaning it moves out of memory. And when that happens, the value went back to what it was supposed to be. This would also happen if you're building it. So what we need is we need some way to save our data forever, essentially. So this is probably the one instance in this entire situation where I'm going to use a singleton to manage some data. I really don't like using singletons because as soon as you have information persist from one scene to another, that information then is very easy as a designer or as a software developer to start to make connections between that and other things. And as soon as you start making those connections, then you run into situations where your design becomes much more rigid, and you want to try to avoid anything that would make your design more rigid. So here's the main idea behind how we're going to do this. We're going to create an item that's going to sit in our room here, and it's going to be a singleton, meaning it's the only one that's ever going to exist of it. And then also, when we go into a new room, it is going to persist in between the rooms. And you would do this by adding a command on it called don't destroy on load. Then, when it enters a new room, it checks the room to see if there's already one of those in there. And if there's not, it just continues to exist. And if there is, then it destroys itself. Now, we're also going to create a save game situation here where we're going to, when we enable the script or the scene, then we're going to load information from what's called a custom binary file, which is a way to save your data into hexadecimal. And when we turn off the game, we're automatically going to save all of our objects to it. And then we could have a situation where the player could press a button that would also trigger a save. But there's only a few things that I specifically want to save. For example, I want to save how many maximum hearts the player has, what their inventory is, how much gold they have, how many keys they have. I don't necessarily want to save them exactly where they were because I want to make this similar to A Link to the Past. In A Link to the Past, when you save, you had the option of restarting if you wanted to start at the Sanctuary, or I think it was the Sanctuary or Death Mountain maybe, or your house. So I want this to be kind of similar to that, where we're not necessarily storing the player's position, but you could extend it to do that as well. You could extend it to save not just, Black's health and everything, but you could also save the player's XY coordinate in a scene and whichever scene they're currently in. All right, so let's get started with this. So the first thing I'm going to do is in my scene here, I'm going to create a new empty object. I'm going to call this empty object Game Save Manager. And then in my scripts folder, I'm going to go to my game section. I'm going to make a Game Save Manager script. That's going to hold this information. Okay, and then I'm going to open this up in Visual Studio, which I actually already had open with a previous version. That should be anyway. Okay, there we go. It's open now. I don't know what was going on there, that it kept opening the one from the sample project I make ahead of time. So what we want to do is we were going to make a reference to itself in here. So we're going to say public Game Save Manager, and we'll just call it, I guess, Game Save. And then we're going to create a method called awake. So void awake. And Unity has a specific hierarchy for how it calls methods. Awake is called at the creation of an object. After awake is onEnable. After onEnable is start. And then I think there's a late start as well. So if you want things to process in a certain order, it will go through everything that needs awake and do those first. Everything that needs enable, do those. Everything that needs start, and so on. So what we want to do here with our awake function is we want to say, okay, sorry for that word cut. We're going to make this a public static game save manager. And we're going to call it game save. Now that static means that this is something that won't change once it's loaded. In general, things can be dynamic, meaning they can be changed, or they can be static, something that's static will not change. Now in the void here, I'm going to say if game save is equal to null. So if there is no game save, then game save is equal to this. And if game save isn't null, meaning if there's already one in the scene, then we're going to say destroy this. Not this.game object, but just this script, so that we don't have more than one of them at a time. Now, that's a common pattern that you'll see, and it's the general idea behind a singleton pattern. You can extend this by making generics or all kinds of other things, but the main idea behind singletons is you want to have only one of something. Now, a lot of times when you're seeing tutorials that are made by people who follow different design patterns than I do, they have a tendency to use the singleton pattern for a lot more than just what I do. For example, instead of saving the player's health or the player's max health into a scriptable object, they will have a tendency to save those on the player themselves and then have the player be a singleton, so that as you move from scene to scene, it's the exact same instance of the player. However, in general, this can lead you to make very rigid connections between objects in your scene. And the reason that's bad, and I've talked about this before, there's a video in the description down below that you can watch by Ryan Hipple, who does a really, really good job of explaining why it's bad. The reason it's bad is if I make these rigid connections between, say, the player and a sound manager and a particle manager or an effects manager or anything like that, and I make sure that those are all, and the camera, and I make sure that those are all singletons, meaning there's only ever going to be one of them, then if I want to do something to the player, so like let's say I want to test out some new function, if I open a new scene and drop my player in, I'll immediately get a reference saying that the player doesn't know where the effects manager is. So I'll drop the effects manager in. The effects manager doesn't know where the sound manager is. I'll drop in the sound manager. Now the player doesn't know where the inventory is. I'll drop in the inventory. Inventory doesn't know where game manager is. So you'll have this situation where you create this dependency between everything, and it kind of breaks some of the fundamental ideas of object-oriented programming, which is why I tend to lean towards a scriptable object pattern or any other pattern that would keep that information separate, so that you're not making a rigid connection, you're making a much more flexible connection. And it's been pointed out to me that I break this design pattern a few times in what I've done, and whenever I've broken it and not followed that design pattern, it's completely just me being a goofball. But in general, that's what you want to make. If you want to make something relatively large in scope, you need to have very, very flexible systems so that you're not coding yourself to death. So sorry, that was a little rant about why I generally don't like using singletons, but in this case I'm fine with it because it's a singleton that we're going to use to maintain a reference to specific objects as we move from scene to scene. So what I'm going to do here on my game save manager, I'm going to add that game save manager script I just made, and I want to show you how having a reference to the scriptable object is going to change things. So what I want to do is I want to make a list of the different objects I want to keep track of. So I'm going to say public list of type scriptable object. I'm just going to call this objects is a new list of type scriptable object. All right. I'm only calling it as a method here. So I'm making a list of scriptable objects. Now we've dealt with arrays so far in this tutorial, but we haven't dealt with lists. A list is very similar to an array. However, there's a lot more functionality because they were added to C# later. And that functionality can be really good for some things. First of all, arrays are generally just one size, whereas a list can dynamically increase or decrease in size. If you want to find if something is inside an array, you usually have to loop through all of the objects and say, what are you, what are you, what are you, what are you? Whereas if you're using a list, you can check to see if the list contains certain items. And there's a whole bunch of other stuff, but lists are good. So I'm going to save this. And I just want to show that just by having this and having this have a reference to the scriptable objects that are in the scene, it's going to make them persist from one scene to another. So I might speed this up because I've shown this like a million times before, but I'm going to show you the bug we currently have, and I'm going to show you the fix for that bug. So here we go. As I hit play, so I'm going to go down to the treasure chest, which has a Boolean value on it that's supposed to persist between scenes. And for some reason it did, well, I know why it did. It did when I tested it, but that's weird. That room does not know where its virtual camera is. What room is that? So I did it like 1, 2, 3, 4, 5, I think. Oh, I call it treasure chest room. This room does not know whose virtual camera it has. That or this virtual camera does not know whose room it has. Or this room, look at that. How did you get down here? What's up with that? I even did that whole episode to fix these. Good Lord. All right. So let's get all of these back up approximately where they're supposed to be, and then I'll put them exactly using the points. So open up the points. Let's put this one at 12.5 and this one at 12.5. Is that right? That's weird. Okay, and then this one is negative 12.5, and then this one is 12.5, and negative 12.5, and negative 12.5, and this should be the last one. Okay, so positive, positive, negative, positive, negative, negative, positive, negative. That's the 4 different versions. Oh, man. Copy component. I did this in play mode. At least I can paste component values. At least I realized it as soon as I did it. Okay, so I'm probably going to fast forward this. So I'm going to go get the key out of the treasure chest down there. And then we'll go from there. So, all right, so I got that key. Now, that treasure chest should remain open, but here's what's going to happen. Actually, let's use the house as an example, because the house has no treasure chests, which means there's nothing in that scene that has a reference to any of the treasure chests, which is going to make it so that the treasure chest will deserialize in between going into this scene. Awesome. What the heck did I do? House interior. Oh, I messed with the prefabs, that's why. Good Lord. You guys get to see me fix a few things here really quickly. Let's save this scene. Let's go to our scenes. House interior. Let's fix this missing prefab. Let's delete you. Prefabs and player and player. Okay, cool. And now, all right, it should know its main position. Yeah, that should be fine. Let's save this and let's jump back to, let's make sure it's going to be fine. Jump back to our scenes. Actually, I should be able to just play from here. because it should have reset the player's position vector value. Oop, I cannot. Player is at 15, -5. All right. So let's go back to sample scene. Player. Okay. So let's try this now. All right, I'm going to speed this up again. I'm going to go to the treasure. Oops. I'm going to go to the treasure chest. I'm going to go back into the room, and then I'll slow down so you guys can see what will happen. So, down to the treasure chest. Okay, so now I'm in here. I'm going to go back out. And I don't even need to go to the treasure chest. I can just show you in the scene view. It's closed again. The reason it's closed again is because in between those two scenes, the scriptable object essentially reset itself. So now, if I go to my game save manager, oh yeah, the other thing I need to add to it to make it be a true singleton is at the very end, I'm going to add don't destroy on load this .game object because I want the whole object to go. All right, so now if I go back to Unity, I'm going to open up my objects. I'm going to just put one thing in here, just one. And that's going to be that treasure chest that I want to save, where I want to save its persistent value. So we'll do one, and then this needs to know the scriptable object. So if I go to my objects, treasure chests, I think has its own thing. Cool. And then the overworld has its own thing too. And then I'm going to grab chest A. And all right, now I'm going to do this whole thing again. Bear with me here. All right, so now that I'm in this new scene, you see that in the hierarchy, there's these two different setups. There's the house interior, which is part of the scene, and then there's this don't destroy on load. And part of the don't destroy on load is the chest A bool value. And since it's holding chest A, it still knows that it's false. So if we go back out here, it should be able to go to the scene view, and it should be open. And there we go. Let me just make sure that everybody knows because the tag is kind of in the way there. So by holding that value in between scenes, we keep it from deserializing, which means that it's still in memory. And you can use this for all kinds of things. You could use this for if you defeated a boss. Like you might have a trigger area in here that maybe brings up a dragon or something, and you want that trigger area to go away. Well, you can use a Boolean value to say whether or not it's there, and then a general game save manager. Oh, I should have just done this. That's my mistake. Because now I'm going to keep getting an extra game save manager. And then you can have a game save manager that keeps a reference to that Boolean value, and then when you switch from scene to scene, it will remain in memory. It will never be deserialized. All right, so let's fix one thing really quickly here. Let's go to our don't destroy unload, and let's make it just be this instead of this set game object. So don't destroy unload this, and then let's do this dot game object so that we're not destroying just the script, we're destroying the whole thing. All right, cool. So now we got to save these objects. Now I'm going to break this video into two pieces. I wasn't initially, but right now we have it so that we're going to be able to save some information. So if there's other information you want to persist from scene to scene that you might not have a reference to, you can add that to this list. So for example, things that I generally want to make sure that I always have values for, let's just set this to 4, but I might need fewer things. I generally want to make sure I always have a value for the number of heart containers so that I always know that. I generally want to make sure I always have a reference to how much magic the player has. I always want to make sure I have a reference to the player's inventory, not necessarily the inventory items themselves, because the inventory can hold those references. And I think that's it for now. Oh yeah, there's another chest I want to make sure I have the value of. So I'll put 5, and then I'll go to my treasure chests, and I'll put in chest B. This isn't super organized. We could break this down further, but for now this is fine. Okay, and now the next video we're going to go over is going to show you how to take this information and make sure that you can save it from play to play as you port this to whatever device you're going to port it to. And the example I'll show you will be just porting it to my little Mac OS desktop. So I'm going to save this. If you have any questions, feel free to ask in the comments down below. You can join my Twitter, find out when I post new videos and just general things. I've been streaming on Twitch lately. I'll put my Twitch link in the description. The Discord is really awesome. There's a lot of really good people there, people who are way better programmers than I am, who are willing to help people out. And I'm, of course, always willing to help people out if I'm in the Discord. So, yeah, I hope everybody has themselves a wonderful day. If you enjoyed this video, consider giving a like, subscribing to the channel, or telling a friend who might be interested. Also, please consider following me on Patreon. For as little as $1 a month, you can earn access to tangible rewards, like early access to videos, backer-only videos and series, polls for future topics, streams, and even individual tutoring sessions. You can find a link to that in the description. And as always, have yourselves a wonderful day.